Okay, now for something so completely different. It's not even really math in terms of adding, subtracting, exponents, square root symbols. It's more about definitions. And we're looking at what's called the real number system. Later on, if you make it, when we go to university and you go into mathematics, there will be unreal numbers or imaginary numbers. So we're not talking about those. We're talking about real numbers. And like, what are real numbers? Well, that's what we're going to get into right now. But let's take a step back before we go there. And there was someone, I don't know who, at some point a long time ago, that said, I want to call the numbers 1, 2, 3, 4, all those really nice numbers, positive numbers, 1, 2, 3, 4, 5, all the way up to infinity. I'm going to call those a name, and I'm going to call them natural numbers. So everybody agreed, and they said natural numbers. That's numbers that are like this, 1, 2, 3, 4, all those really nice positive numbers all the way up to infinity. And then someone else came along a short while later, and they said, well, I want to come up with my own list of numbers, and mine's going to be identical to yours, but I'm going to call it whole numbers. And we're like, why? And they're like, because I'm going to include the number 0. And everyone said, okay, so whole numbers. Start with 0, and we're going to count up 1, 2, 3, 4, ... Go all the way up to infinity. And which set of numbers is bigger? Well, whole numbers, because it includes one extra number that's 0. Now, someone came by shortly after that and said, you know what? I'm going to come up with another set of numbers, and mine's going to be completely different than yours because they're going to be negatives as well. They're going to have everything yours has, but it's also going to include negative numbers. So, you got your 0, and you got your 1, and you have your 2, and you have your 3, and you go all the way up to infinity. Those are all your whole numbers, but I'm also going to have -1, and -2, and -3, and go all the way down that way. And I'm going to call my number set integers. So if we had to rank the smallest one, well, okay, natural numbers are the smallest. And then we have whole numbers, and someone said we're going to add 0, so that's whole numbers, so that's the next one. So this is the second smallest. And then, like we said, integers, they're going to have all of those numbers, but we're also going to make sure that we have all of these negative numbers. And someone came up to them as well, and we're like, okay, that's great. You've got 1, 2, 3, 4, 5, that you have 0 included, and you, integers, you have all these negative numbers. I'm going to have all of those numbers as well, but I'm also going to have fractions. I'm going to have things like 0 and 1 and 2 and all of those things, and I'm going to have -1 and -2 and all of those, but I'm also going to have numbers like 3/2, or -7 over 100, or -9/13. And we're going to have all of these numbers. So they can be positive, they can be negative. In fact, I say anything that can be expressed as a fraction, because technically, all of you guys up here in the natural numbers, you're all fractions as well. You're 1/1, and 2/1, and 3/1, and 4/1. All of those are technically still fractions. So I'm going to call mine, the next one, rationals. I'm going to call this is the fourth smallest one. And they are going to be everything, any whole number, any integer, positive, negative, plus any fraction. And we have a test. Sometimes when we do these, like if you have 3/2, 3/2 is 1.5. We call that terminating. It has a decimal place, it just terminates. Or say you have a quarter. A quarter is 0.25. It just stops. But then we also have, this was 3/2, right? But we also have things like 1/3. 1/3 is 0.333333. It repeats. So if you have any number, like any fraction that terminates, like these two, or it repeats, like this one, or if it is written as a fraction, or if it looks like just any sort of positive or negative whole number like that, that is what we're going to call rational numbers. And you think that would be it, but it's not. Someone else said, well, what about pi? Because pi has a decimal place of 3.141592, and it goes on forever, and it's not repeating. This does not repeat. It's random, and it doesn't terminate like these ones do. No, it goes on forever. So what about these numbers that are not fractions, and when they're in decimal place form, they don't repeat and they just go on forever? Or a number like, you probably know what the square root of 4 is. The square root of 4 is 2, but if you've ever done the square root of 5. So if you do the square root of 5, you'd find that you would get 2.236067, just a bunch of random numbers that go on forever. So what about random decimals that go on forever? What are those going to be called? So what they did is they gave those a special name. And they gave them irrational numbers. Sorry, I was going to highlight that, but apparently I crossed it off. Irrational numbers. And those are numbers that cannot be expressed as a ratio or a fraction. So they can't be expressed. And you can see there's a test there. They cannot. That's the biggest thing. They cannot be a decimal place that terminates or repeats. They can't. So what are some examples? There's a million of them. There's the square root of 5 that I did. Square root of 6, that just will go on forever. Square root of 7, that'll go on forever. Square root of 8, that'll go on forever. Square root of 9, that's 3. No, that's not going to work. 3 is okay. Square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15, square root of 16. Oh no, that's 4. Right? Like it'll just keep going on forever. One of the popular ones is pi, because that's just a bunch of 3.1-ish, and it goes on forever and it's random. These are all numbers that cannot be turned into a decimal that repeats or terminates. So what you have off to the side here is you have imaginary numbers. We don't know what those are. But then we have real numbers. And we're splitting them up. We've got the irrational numbers. Those are ones that, like I just said, that they like pi and square root of 5, square root of 6. They have a decimal that goes on forever. And then on the other side of it, we have rationals. And those are anything that can be written as a fraction. And together, they make up the real number system. And that's what we see down below here. You see, we've got all the real numbers. All of these things are real numbers. And on one side, you've got all those irrationals. And you might want to put something like pi or the square root of 5. Those are irrationals. You can go i.e. But then on the other side, you've got rationals. Those are things like 3 over 2 or 1 over 4. Maybe make it negative. Or even 7, because 7 is technically 7 over 1. So on one side, you've got all the things that have random decimals, and then you have on the other side things with decimals that terminate. Even 7. 7 is 7.0. It just stops. It terminates. So all whole numbers, all integers like that, they terminate. And we kind of break them up here. So you've got your natural numbers. the positive ones, then the whole numbers where I guess they add 0, and here where they add the negatives, and here where they have all of those things, but they also have the 3 halves and the 1/4 and all that sort of stuff. So we don't break that down on this side. That side is just all random numbers that have, random decimals that go on forever. But this side is ones with decimals that end or repeat. And then we kind of have these little subsets that go below. So we have some questions that we're going to ask. But if you wanted to, you could write those are rationals. Integers, you could put i.e. -7 or 15, right? Because you can have negative numbers and positive numbers. Whole numbers, well, that's the one where it has the 0 in it. And natural numbers, that's the ones like +15, +16, all those sorts of things. So you can take a look at the notes and see that I've filled this out a little bit, but I'm going to do one more example, a video or two where we actually do some examples of this.